Today we're going to take a look at stoichiometry worksheet that has three problems on it. It starts off with an iron nitrate compound reacting. So let's take a closer look at what we have here. Okay, let's look at our couple of questions on our first part of our worksheet. Notice the first question is to balance the equation. We need to balance the equation by taking the three irons that we have here. So we've got 3 in front of the iron 2 nitrate. That's going to give me the fact that we have 2 phosphates. We need a 2 in front of that. That's going to give me 6 potassium. So we have a 6 in front of the KNO3. Pretty straightforward. Naming these, we've got iron 2 nitrate and potassium phosphate. Products are going to be iron 2 phosphate and potassium nitrate. Notice when we calculate the molar mass of iron 2 nitrate, we're going to have iron at 55.8. We've got 2 nitrogens at 14.0 each. We've got 6 oxygen at 16. Gives me a grand total of 179.8 grams per mole. Okay, it should be pretty obvious in the next question that if we produce 1 mole of potassium phosphate, the number of moles of iron 2 nitrate that are required is going to be 3. So the answer to number 4 is of course 3 moles of iron 3 nitrate. Get down here to number 5 and we have this situation. We are given the number of moles of the iron 3 phosphate and we're looking for moles of potassium phosphate. Notice that to go from a 1 to a 2, we multiply that by 2. So we'll simply multiply this number of moles by 2 and we get 0.764 moles, and there's our final answer. Then in number 6, notice we are given 0.1 moles of iron 2 nitrate and we're looking for moles of the insoluble product. Again, we're looking at a mole-mole ratio here. To get from 3 to 1, we can multiply by 1/3 or divide by 3. So we can multiply by 1/3 here, and we multiply that times 0.1. Of course, we get 0.0333 moles of our insoluble product. Okay, our next reaction is between propane burning in oxygen to produce carbon dioxide and water. And to balance that, we need 3 carbons. So we need 3 carbons over here. We've got 8 hydrogens, so we need 8 hydrogens. So we'll stick a 4 in front of the water. That gives me a total of 10 oxygens. And so 5 times 2 is 10 oxygens. Combine that with question number 8. It says if 3 moles of propane react, how many moles of carbon dioxide will produce? Well, there's a 1 there. To get from a 1 to 3, we simply multiply by 3. So the actual number of moles are also going to be multiplied by 3, and so we get 9 moles of carbon dioxide being produced. Then if we look at number 9, we notice that we're given 5 grams of carbon dioxide and we're looking for moles of propane. So what we want to do is to convert to moles. So we've got 5 grams of carbon dioxide multiplied by a conversion factor to go from grams of CO2 to moles of CO2. 1 mole of carbon dioxide weighs 44 grams. So we'll take 5 grams, divide it by 44, and we get 0.114. So we've got 0.114 moles of carbon dioxide. Now, how many moles of propane do we have? Well, go back to our mole ratio. We've got 3 to 1. To get from a 3 to a 1, we multiply by 1/3. So we'll multiply this by 1/3. And so we take our 0.114, multiply that by 1/3, and we get 0.0378. So we got 0.0378 moles of propane, and there's our final answer. Okay, number 10, we're given that we have 0.5 liters of carbon dioxide, and we're looking for liters of propane. So our first step then is to convert to moles of carbon dioxide. From there we're going to find moles of propane, and then we're going to convert back to liters of propane. So to convert 0.5 liters of carbon dioxide, we're going to multiply by 22.4 liters on the bottom, which of course is equal to 1 mole of carbon dioxide on top. So that's going to give me 0.5 divided by 22.4, which is 0.0223. 0.0223 moles of carbon dioxide. 0.0223. Now, to get from a 3 to 1, what do we simply do? We can divide by 3. So to define the actual number of moles of propane, we'll simply divide by 3. So here's our 0.0223. We'll divide that by 3. We get 0.00744. 0.00744 moles of propane. Now, we then want to take our 0.00744 moles of propane and determine the number of liters. So we're going to have 1 mole of propane on the bottom, and we need liters of propane on top. And of course we know in 1 mole there's 22.4 liters. So we multiply. Again we have this 22.4, and we get 0.167 liters of propane. But now there's something kind of interesting going on here. Again, look at the 0.5 liters of propane. What if we simply took the 0.5 and divided that by 3? Take our 0.5, divided that by 3, what do we get? 0.167, which is the same as our liters over here. So what we've just discovered is that the volumes are in the same ratio as the coefficients in the balanced equation. This was discovered quite a few years ago by a Frenchman by the name of Gay-Lussac. Stop giggling, that's his name, Gay-Lussac. And so what we're going to find then, a little bit later on, we'll talk about, when we talk about gas laws, we'll talk about Gay-Lussac's law of combining volumes. Okay, in question number 11, we're given we've got 4.5 grams of propane. We're looking for grams of carbon dioxide produced. So we're going to do the routine. Start with the mass. We're going to find the number of moles of propane. We're going to find the number of moles of carbon dioxide and convert back to grams. Here we see that we've got 4.5 grams of propane. We multiply by a conversion factor with 44 grams on the bottom so that the grams cancel, and we end up with 0.102 moles of propane. So we have our 0.102 moles here. Again, we look at our coefficients. Here's our invisible 1. To get from 1 to 3, we'll multiply by 3. To get from moles of propane to moles of carbon dioxide, we'll multiply by 3. And so we end up with 0.102 times 3 is 0.306. We didn't really need to do that. 0.306 moles. So we'll come down here, 0.306 moles of carbon dioxide. And we're going to go from moles of CO2 to grams of CO2. 1 mole weighs 44.0 grams. So we multiply that times 44, and we end up with 13.5 grams of carbon dioxide. And there's our answer. Okay, number 12, we're given we have 10 liters of propane, and we're looking for the grams of water that's produced. And you know the drill. We go from liters to moles, find moles of what we're looking for, convert it back into grams. Okay, we start off with 10 liters of propane. We multiply by a conversion factor with liters on the bottom, moles on the top, and we get 0.446 moles of propane. So we've got our 0.446 moles of propane. Now notice the mole ratio. To get from a 1 to a 4, we're going to multiply by 4. So down here we're going to multiply by 4. So we got 10. Our original 10 was divided by 22.4. Okay, and then we're going to multiply that by 4. So we end up with 1.79 moles of water that's produced. So we've got 1.79 moles of water, and we're going to convert from moles of water to grams of water. 1 mole weighs 18 grams, and here's our 1.79 times 18. We get 32.1 grams of water, and there's our final answer.